everybody. I hope you're having a great day on this Tuesday. As we do a little more science review this week, we are going to review our unit on water. And we're going to talk about half of it today and half of it on Thursday. And both days you're going to have some STEM scopes work to practice through. Now, some of it you might have done or seen the videos way back in the fall, but it's been a while, so I thought it would be fun to look at it again, even if you've seen it before. You've learned so much more since then, so I'm sure you'll do even better with it this time than you did last time. Also, there is another video that I made, and I show you how to make a water cycle at home. So if you haven't watched that yet, go ahead and watch it, and that's a fun activity you can do at home with simple things you already have around the house, just so you can get some real-life science happening this week. So today we're going to go through our slides for day one. You're going to need to pull up your slideshow. It's just called Water Review. And again, some of these slides you saw earlier in the year, I've updated them a little bit, but it's been so long since we've looked at them, I thought it would be great to look at them again and think about them with a fresh outlook now that we are so much further along in the year and we've learned so much more science, and see if we notice or discover things that we didn't think of back then. So click onto your first activating slide under day one, and if you remember, we saw these pictures a long time ago, but I want you to refresh your mind and think about those pictures. What are they showing, and what do they remind you of that we learned? What do they make you think about? Maybe you still wonder something about them. Go ahead and click to the second one, and you're going to see 3 different slides. I want you to be thinking about, oh yeah, I remember what that is, or I remember what that process is called, because before you saw these slides, you didn't know those things yet. All right, one more activating slide to look at. Those pictures all look very refreshing on that one. I like those a lot. Okay, so if you remember back, go ahead and click to your first mini lesson slide. If you remember back to our unit on water, we thought about these questions. What do those pictures have in common? And what is different from those pictures? Now, we know that the first pictures showed different types of ice. The second pictures showed different type of water vapor or gas. And the third set of pictures showed liquid water. Now, if you remember, those are the different states of water. Ice is a solid, the water vapor is a gas, and then liquid water is liquid. We also need to remember that water is made up of matter, which is the tiny, tiny, tiny molecules or particles. And depending on what state the water is in, those particles are arranged differently. Now, there's a video link on this slide. If you want to rewatch that, you can go ahead and pause the video, watch that. It'll get your mind thinking back about the states of water, and then click back into this video. Okay, so click to the next mini lesson slide, and you'll remember that pure water is tasteless, odorless, and colorless. So it's just clear and plain. It can occur in 3 states, like we just mentioned: solid, liquid, or gas. So first, let's talk about liquid water. It's wet and it's fluid. That means it moves. It will take the shape of whatever container it is in. So it could maybe be a water bottle or a glass or a mug, a bowl, a bathtub. Whatever you put water in, it will take the shape of that container. Now, if it doesn't have a container to sit in or to be in, it will spill, all right, and it will spread out. The molecules in liquid water are pretty close together, but they're not so tightly packed that they can't move around. So they move around each other a little bit. All right, click to the next slide, and you're going to see solid water. Solid water is ice that has ice is liquid water that has frozen into a solid. Now, ice keeps its shape even if it's removed from a container. So if you pop an ice cube out of an ice cube tray, it's going to stay in that same shape. Now, it's going to start to melt eventually, and then its shape will change. But originally, if we take ice out of something, it stays in that shape. The water molecules in ice are packed very tightly together, and they cannot move around. All right, finally, water as a gas. Water vapor is always present in the air around us. It's around you right now. It's around me right now. It's outside. It's everywhere. Now, we can't see it, but it's there. Gas also takes the shape of its container, but if the container is opened, it will escape. water molecules and gas are spread out and they can easily move around past each other. An example of that, the gas escaping, is on the slide we looked at a few minutes ago. You saw the tea kettle on the stove with the water vapor coming out of it. The gas has come out of its container and is escaping into the air. And those molecules are so loosely packed that it's able to flow through the air. Okay, click on to the next slide. And we need to remember how water changes from one form to another. And if you remember, this happens by heat energy being added to or removed from one of those states of water. Okay, so heat energy transforms solids into liquids. That happens at a material's melting point. And we're going to talk about melting point, boiling point, and freezing point in just a minute. If enough heat energy is added to ice, which is a solid, it will begin to melt and turn into a liquid. So adding that heat energy will cause the solid to turn into liquid. In the same way, enough heat energy being added to liquid water will cause it to change into a water vapor or gas form. And that happens if enough heat is added to bring that water to its boiling point. You can see that happen, like I just said a minute ago, on the stove. If you're boiling water to make tea or to make pasta, once that water starts boiling, those gas vapors are evaporating. They're coming up out of the liquid water as what we see as steam. Okay, now removing heat can also cause water to change forms, just like adding heat. So if we remove heat from a water vapor or a gas, it becomes liquid again. That happens when those water droplets get up into, gas gets up into the atmosphere and it gets so cold that it turns back into water droplets, which is how we have clouds. The reverse of melting, which is called freezing, that's when enough heat energy is removed from water that it slows the molecules down, they move closer together, and they turn back into a solid. Another example of gas becoming liquid is when water molecules in the air bump against your glass of ice water or lemonade or some icy drink you have, and when they hit the edge of the glass, they turn back into a liquid, which is condensation. Okay, next slide. We have just talked about how adding or removing heat energy changes water from one form to another. And now you have to remember also the exact points that those happens, the temperatures when those happen. So there's a freezing point, there's a boiling point, and a melting point for water. All right, the freezing point on your next slide is 0 degrees Celsius, which is the same as 32 degrees Fahrenheit. And if you remember, we looked at thermometers, and on each side, one said 0, one said 32. That is the freezing point. If enough heat energy is removed from liquid water that it reaches that temperature, 0 degrees Celsius or 32 degrees Fahrenheit, it will freeze and change into a solid, okay? And you can think of some examples of that happening. I know at my house, we fill up our ice cube trays, put them in the freezer, and once they've reached that temperature, they become nice, hard ice. Okay, next is boiling point. The boiling point for water is 100 degrees Celsius and 212 degrees Fahrenheit. This is what happens when enough heat energy is added to liquid water that it begins to boil, and some of the water changes into a water vapor or a gas. And you can think of some examples of that happening. You probably see them on your stove, or maybe in a really hot bath you might see some of that. Hopefully it's not too hot for that though. Okay, finally, melting point. This is when enough heat energy is removed that the temperature drops to 0 degrees Celsius or 32 degrees Fahrenheit. Oh no, I just said the wrong thing. I'm sorry. Melting point. I was thinking back to freezing point. Excuse me. Melting point for water is just above 0 degrees. So if you've taken an ice cube out of the freezer and the temperature, it's got more heat energy in it and it goes above 0 degrees, that's when it starts to melt and changes from a solid back into a liquid, okay? So you can think of some examples of that around the house. And on our summary slide today, we've reviewed the states of water, we've discussed the differences between these states, and what happens to cause the water to change from one state to another. You're going to work with this on your STEM Scopes activity today. And then the next time we meet on Thursday for science, we are going to review the water cycle. And you'll have some more practice with that on STEM Scopes. You might be making your one at home that you can be observing in your own house or outside in your yard. All right, I hope you have fun with water this week. If you have any questions, please let your teacher know, and we will be happy to help you. And we are so proud of the work you're doing. We miss you, and we will see you soon. Bye, guys.